Okay students, so let's continue the class. The next question is y equal to 10 by 5 plus x plus 2t whole square. Now in this particular question, we have to first find direction of motion of wave. Direction of motion of wave. Okay. Second, speed of wave. And third, it's its amplitude. This we have to find. So what do you do? First see the function. Okay, it's x plus 2t. Now here is plus. That means it's moving towards negative x-axis. So we write first question's answer. Moving towards negative x-axis. Okay. Second thing, speed of the wave. So what do you do then? We know that what is this form? You compare it with kx plus omega t. So we are comparing it. K value 1, omega value 2. So v equal to omega by 2, that is 2 meter per second. Towards negative x-axis. Third is amplitude. The amplitude means maximum value of y. Now when can this have maximum value? When the denominator is minimum. When denominator can be minimum, then this can be 0. When this can be 0, because this cannot be negative, because square is there. This term can be negative, but because of square will become always positive. So what is the minimum value of x plus 2t whole square? 0. So if this is 0, y value comes as 2. So amplitude of the wave is that clear? So these kinds of questions are done in this way. Okay. Now let's go on to the next topic. What is that topic now? Speed. Speed of transverse wave. And which transverse wave are we talking? We are talking about wave in string. Okay. So the next topic is speed of wave in string. Okay. Now how to find it? Just see that clearly. If you are talking about a wave in string, that means we are talking about a transverse wave. Okay. And any string will definitely have some or the other mass. Okay. If I say that its length is L, the string's length is L, and its mass of string is M. Okay. M units, this is L units. So these curves that the string is making definitely are made from circles. Any curve, any curvature actually is made from circle only. How can we say? If suppose I am going to make circles over here, let's see, this part belonging to this circle. Which part? This part. This part here belongs to some other circle. This part. Okay, same way this one will be belonging to different circle, something like this, from here to here. So every part of this, any curve in fact, not only string, not only sine function, any curve is there, we can say that that is made from various circles. Okay, in parabola or in projectile motion, we found radius of curvature also. There also what we said that this curvature is also made from the circles, and at a particular point wherever the radius of curvature was asked, you remember that we made a circle over there, okay, and we found out radius of curvature there. So exactly same concept we are applying in this one also. We are saying that here also we can say that the curves of this string, wave in string, are actually made from circle. So if suppose we have a part over here, something like this, and in this part we say that this is a circle. Okay, and this part of the string actually is part of this circle. Okay, its radius is r. Let's assume. Okay, now if this is a circle, and since wave is moving in this direction with v, wave is not at rest. Okay, wave keeps on moving in this direction. So what happens? This part here will be subjected to a centrifugal force. This part will be subjected to centrifugal force. What is that? dm v square by r. Okay, dm v square by r, which will be acting upwards. And in this direction here, there will be tension, and in this direction also there will be tension. So this tension, we can have components, one horizontal and one vertical direction. Same way here also, horizontal and vertical direction. Okay. Now if we say that the angle here, this angle is theta, okay, then this angle also can be proved as theta only, because this is theta, so this is theta. This will become 90 minus theta, so this will become theta. Okay. So this component of tension here will become T cos theta, here also T cos theta, whereas this T sin theta and this also is T sin theta. What we can write then? This dm v square by r, which is the centrifugal force, must be balanced by 2T sin theta, which will not allow this string to move further upwards. Okay, so they need to balance each other. So 2T sin theta equal to dm. What is dm? dm is the mass of this small portion that we have considered. Okay, what about this theta? If this is very small length, so obviously theta also will be very small. So sin theta we can write as theta only. If theta is very small, sin theta will become theta. And what we can write this dm? This dm is what? You can say it is mass by length into small length. Okay, this is dx. This is dx into v square by r. Okay, now if this is dx, this dx we can write as length of arc. Length of arc formula is what? Length of arc is equal to radius into angle subtended at the center. So this is theta, this is also theta. So total angle subtended at the center is 2 theta. So this dx value I can write as radius into angle subtended at the center. R gets cancelled. Here 2 theta gets cancelled. Okay, and this mass by length we are going to represent with mu. We call this as linear mass density. So mu into v square equal to t. So v square equal to t by mu, or v equal to root over t by mu. Okay, this is the speed of wave in string. This is the speed with which our wave is moving in the string. String is at rest. String is at rest, but wave is moving. Remember that always. Who is moving? Wave is moving. String will remain here only. String will not move like this. Only energy is going to move like this. Whereas string, the mass motion is not there along the string. Particles are only vibrating perpendicularly. Okay, so this is very important formula. V equal to root over t by mu, velocity of wave in string. Okay, I hope it's clear to you. Now, based on this, there are certain questions that we are going to solve right now. Suppose we have a string and a mass m is hanging with it. Okay, its linear mass density you can consider as mu kg per meter, and its length is L. Okay, so what we know in this one, here there is a force mg and there will be tension. Okay, now if I say this mu kg per meter, and what is the length of the string? L. So what is the total mass of string? Total mass of string is mu into L kg. How can we say? Because this is given mu kg per meter. How many meters this is? L meters. So its mass will become mu L kg. Now if we say mu L is very small, as compared to m. Okay, if mu L is very small as compared to m, then we can say throughout the string, tension will be due to this mass only. Okay, if mass of the string is very small as compared to the mass of this block, then we will say tension will be due to this mass only and it will be uniform. If that is the case, then we can say the speed of the wave, whose formula is root over T by mu, we can say that is m g by mu. What is mu? Mass of the string by its length. Okay, mass of the string by its length. So its answer will be this. Remember that always. Now, second case I am taking. Second case is, in this particular case, string is having mass, okay, and we have to find what is the velocity of wave in it. There is a string here. Okay, its length is L and mass is M. Okay, we are producing a wave. A wave is produced at the bottom. Okay, the first thing is what is its velocity, and second thing, how much time it takes to move from here to here. Okay, find velocity of wave and how much time it takes to reach the top. Okay, fine. Now we know that the speed of the wave is given as root over T by mu. Okay, now because there is no mass suspended with the string only is having mass m. Now what will happen? The tension at every point in this string is different. Why? Because if I talk tension over at this point, this tension is because of this portion of the string. If I talk about the tension here, then it will be because of this entire. But if I talk about tension at the top, it will be due to entire mass. So tension is different at different points. What does that mean? It means is the speed also will be different at different points. Now how to find it? Let's see. So suppose I am going to take tension at this point here, and I am considering this length is x. Alright, so first thing that we want is how much is the mass of this portion whose length is x. What we know? We know that L length is having mass m. L length mass is m. Then x length mass will be what? M by L into x. So what will be tension then? Tension will be mass of this length into g. That means m by L x. Let's put it into this form. So V equal to m by L x g by mu. Mu means what? Mass by length. What is mass of the string? M. What is length? L. M by L square. This and this gets cancelled. What are we getting speed? Root x. So different speed at different point. Here what is the speed of the wave? 0. Here what is the speed of the wave? Root Lg, because x value here will become L. So at every point speed of the wave is different. Okay. What is the formula? Root xt. Now the question, third question is how much time it takes to reach at top. How much time our wave is going to take to reach at the top. We have its speed root xt, but it is variable. It is a variable speed. Okay, what shall we do? We will be writing as dx by dt. Okay, this is what? X is in this direction here. Don't consider that this is y right now, because we have considered it as x. So that's why I am writing this velocity as dx by dt. Don't get confused. Then what? We'll be writing dx by root x equal to root g dt. So from where to where it has to go? From 0 to L. Put 0 to L. here 0 to t. Okay, so dx by root x, this can be written as x to the power minus 1 by 2 dx also, and here root g and t directly we can write x to the power minus 1 by 2, that means its integration minus 1 by 2 plus 1 by minus 1 by 2 plus 1, 0 to L, and here again root gt. What's going to come? This is root x, and here half, so it will be like 2 root x. Put the limit, root g t. So our answer will come 2, here will come first L, then 0. So 2 root L by root g equal to t. This is the answer. Okay, so if there is a string of mass m and it is asked from you what is the speed of the wave and how much time it takes to move from one point to the other, this is the method. Third type will be when there is a mass also hanging and the string is also having considerable mass. In that case, what will be? Something like this. The string and then the mass. This is m, and this is L. So this m may be less than m, but not very less than. That means it's a considerable mass. You cannot ignore it. Now in this case, what you will do? The first thing, again very similar, you find tension at this point, considering this is x. So what will be tension over here? This entire mass plus this mass. So this tension is mg plus m by L xg. Okay, then v equal to root over t by mu. So g taken common, m plus mx by L by mu. What is mu? M by L. This will be the speed. Okay, further we can solve this one. G ml plus mx by m. This is if time we have to find again we can write this as dx by dt and we can solve it. Okay, so that's it for today. That's it for today's class. Thank you very much.